Okay, so we're looking at the charges, okay, associated with each column on the periodic table. Okay, and looking at those charges, okay, you see that we've got a +1 charge associated with the first column. Well, they have one valence electron, group one valence electron. Okay, the reason why they have a +1 charge is because they will lose one electron when they form an ion. Okay, and again, that goes back to our electron dot diagrams here. Okay, it's easier for hydrogen and lithium and sodium to lose one electron than to gain 1, 2, 3, 4, 5, 6, 7 electrons to become like the noble gases. Okay, a lot easier for sodium to lose one electron and to become like neon than it is for it to try to gain 7 to become like argon. Okay, and when we talk about valence electrons, remember those are the electrons that are in the outermost shell. Okay, so right now sodium has one atom or one electron in its outermost shell. Okay, if we go back and look here, hey, here's sodium. If it loses this one electron, right, that's up here at the top, if it loses that electron, you'll see that essentially that outermost shell becomes empty. There's nothing, there'll be nothing there. And it'll be left with a full second shell. 1, 2, 3, 4, 5, 6, 7, 8 electrons in that second shell. Okay, atoms like chlorine. Okay, chlorine is over here, right? Its valence number is 7. It's got 7 valence electrons. Okay, so those 7 valence electrons, it wants one more. Okay, if it gains one more electron, let's say from sodium, okay, if it gains an electron, now it's got 1, 2, 3, 4, 5, 6, 7, 8. So its outermost shell will be filled, okay, if it gains one electron. Remember, electrons are negatively charged. That's why if we have more electrons, okay, than protons, our atoms will be negatively charged. And in the case of sodium, we lose an electron. If we lose an electron, our atom becomes positively charged. Okay, so this gives us the most common charges up here at the top for our different columns on the periodic table. These guys are 0 because they're not going to form ions because their outermost shells are already full. Okay, so then we're moving on to our actual activity. Okay, the first thing you guys are going to do in your activity is figure out, okay, the answers to these questions. Okay, so are cations positive or is it anions? Okay, and then have they lost electrons or have they gained electrons? Okay, so positive ions are going to be cations. Okay, and they have, because they're positive, that means they have more protons than electrons. In order for that to happen, they had to lose electrons, okay, in order to become positively charged. Okay, we have 3 different pieces that represent these positive ions. Okay, down below, negative ions, a negative ion, anions. Okay, anions have gained electrons. Okay, and these 3 shapes represent anions, okay, that have extra electrons. More electrons means more negative charges. That's why these form negative ions. Okay, so we're going to look at our first actual ionic compound, calcium oxide. Okay, that's the name of the compound. Okay, it's formed by 2 ions, a cation, calcium, okay, and an anion, an oxygen ion. The calcium ion has a +2 charge, and the oxygen ion has a -2 charge. Okay, so if we put together our calcium and our oxygen ions, right, the reason why they come together is because they have opposite charges, so opposite charges attract. Okay, we've got a +2, it will cancel out the -2 ion, and that will make a neutral compound. Okay, that neutral compound, when I look at the ratio of cations to anions, I have 1 calcium ion to 1 oxygen ion. And the formula then is going to be Ca, okay, and the other atom is oxygen, okay, and the subscripts associated with calcium, there's 1 calcium atom, or 1 calcium ion, and how many oxygen ions are there? Okay, there's also 1. Okay, so that ends up being, okay, the formula for this ionic compound. Okay, so we find the ratio of cations to anions. Okay, then we're going to move along to slide number 5. Okay, and slide number 5, okay, we have sodium ions and sulfur ions. Okay, we always start with the positive ions, the cations. Okay, 2 sodium ions can kind of fit in our little model space. And then how many negative ions do we need, okay, in order to build our model? Okay, and kind of fill in that model space, we need 1. Okay, and that means that now I have 2 negative charges, or sulfur -2, and then I have 1 sodium that's a +1, and another sodium that's a +1. Okay, that means they'll cancel out. The end result, we end up with a ratio. Okay, that ratio, I don't know why I have sodium there, not thinking, right? Okay, is 2 to 1. Okay, and then I go to write the formula. Okay, the formula is Na. Okay, with a subscript, there are 2 sodiums. Okay, to every, for sulfur, there is 1. Okay, so it's Na2, 1. Okay, let me go back a second. Okay, so that's, okay, our second example. Okay, so our second example, okay, for sodium sulfide. Okay, and again, remember these are ionic compounds. Ionic compounds are always going to combine metals with nonmetals. Okay, metals, nonmetals form ionic compounds. Okay, and the metal in this case is the positive ion, the sodium, and the nonmetal is sulfur. Okay, that's the negative ion. Okay, one last example together. Okay, for iron nitride, okay, I have 1 iron ion. Okay, it will match up perfectly with 1 nitrogen ion. Okay, iron has a +3 charge, nitrogen has a -3 charge, so they cancel each other out. We end up with, again, a 1 to 1 ratio. And our formula then will be Fe for iron, N for nitrogen, and the subscript on iron will be 1. The subscript on nitrogen will be 1. Okay, so from here, you guys are going to move on to number 7. Okay, and number 7, oh, sorry, I don't know why I went backwards. Okay, in number 7, we just went through and did this one. Oh, no, this is iron nitride. Sorry, we were working on number 6 before. Iron 3 nitride. Okay, this is iron 2 nitride. Okay, kind of funky, right? They have the same name, but it's 2 versus 3. Okay, iron 2 nitride will have 3 irons. Okay, how many nitrogen ions will they need in order to cancel out these 6 positive charges associated with iron? Okay, so that's what you guys are going to figure out. You're going to fill in the rest of this. Okay, and then you'll move on to slide, the next slide. You'll fill in slide 8, 9, and 10. And then we'll get to slide 11. Okay, so I want you guys to complete slide 8. Well, finish 7. Okay, do 8, 9, and 10. Once you're finished with all of those, okay, unpause the video and I'll go over how to do slide 11 with you. Okay, so you should pause now, finish up to slide 10, make sure you have everything. Okay, and then I'll show you how to do slide 11. I'll give you a second to get that taken care of. Okay, hopefully you have answers for all of these. I'm just going to go back. Let's just look at them kind of mentally. I can look at it and say, okay, for slide number 8, that should be Na1Cl1. And for lithium and bromine, okay, lithium and bromine, it should be Li1Br1. And then for calcium and bromine, okay, calcium has a +2 charge, bromine has a -1 charge, so it should be Ca1Br2. Okay, so that's how you can double check your formulas there. And then let's look at slide 11 together. Okay, in slide 11, you're finding the number of protons in our atoms. To find the number of protons, you're going to look down here at the bottom. Okay, down in the bottom, you're looking at this little periodic table. Okay, the periodic table has the atomic numbers. The atomic numbers tell us the number of protons in the atom. Okay, so sodium's symbol is Na. Okay, so I find sodium has 11 protons. Okay, then I move on to chlorine. Okay, chlorine is over here. It has 17 protons. Magnesium, okay, is right here. It has 12. Calcium right below it has 20. Oxygen over here has 8. And phosphorus has 15. Okay, so you're filling in that whole chart. Okay, once you have that part of the chart completed, okay, because our atoms are neutral, they have to have equal numbers of protons that are positively charged and electrons that are negatively charged. Okay, so our sodium, if we have 11 protons, we also need 11 electrons for it to be a neutral atom. Okay, so our number of electrons, okay, for sodium is 11. Okay, for chlorine, 17, magnesium, 12, calcium, 20. Okay, once we fill out that whole chart on the number of electrons, then we're going to figure out the number of valence electrons. I talked about this at the beginning. The number of valence electrons has to do with what group our elements are part of. Okay, so sodium is in group 1. Remember, its symbol is Na. So that means sodium has 1 valence electron. And you can also go back and look at the very first slide where you see the electron dot diagrams. Okay, chlorine over here is in group 17. Group 17 is 1 away from our noble gases. So instead of having 8, a full shell, they have 1 less. They have 7 valence electrons. Okay, so it's associated with the ones place. Okay, so chlorine has 7 valence electrons. Then I find magnesium is over here. It's in column 2. Okay, that means it has 2 valence electrons. Okay, calcium is in the same column. So elements in the same column have the same number of valence electrons. So calcium also has 2. Okay, and then the charge on the ion. Okay, at the top up here, remember this is where the ion charges are found. Okay, and that's what charge these atoms would have when they form ions. Okay, so hydrogen, lithium, sodium, potassium, they're going to form +1 ions. So sodium, a +1 ion, okay, because they are going to try to lose an electron. Okay, chlorine over here wants to gain 1 electron to get up to 8. So if it gains 1 electron, it would form a -1 or a 1- ion. Magnesium is over here. It has 2 valence electrons. 2 is closer to 0 than it is to 8. So that means magnesium is most likely to lose 2 electrons. So it would form a +2 ion. Okay, so fill out the rest of this chart. Okay, and then we need to work on what's over here. Okay, this is another method of figuring out what ionic compound, okay, 2 elements would form. Okay, and when we talk about these 2 elements, that means that these 2 elements have to react. Okay, and if they react with each other, okay, when they react, bonds will form. Okay, and in the case of these atoms, because we have a metal and a non-metal, the type of bond that's formed is an ionic bond. And remember, ionic bonds are formed because we have a positive ion and a negative ion that are attracted to each other. They get pulled together. And when they get pulled together, they form a bond or a link. Okay, so how do we, without having our pictures, which is what we had in the previous slides, without having our pictures, how can we figure out what combination of sodium and chlorine, okay, would combine together to make an ionic compound, okay, that would be neutral? Okay, we're going to use what's called the crisscross method. Okay, in the crisscross method, you write the two elements that are involved with the charge of the ion that they're most likely to form. Okay, so magnesium is a +2 ion. Okay, so +2. Bromine, okay, is most likely to form a -1. Bromine isn't on our chart, but bromine, if I continue down this column, it's in column 17. Okay, and in the crisscross method, the number that's associated with the cation or the metal, that charge, that number, will become the subscript for the anion and vice versa. Okay, so magnesium bromide, okay, magnesium has a subscript of 1. Remember, if there's no number written there, there's an imaginary 1 there. Okay, bromine has a subscript of 2. Okay, and the reason why it's 2 is to balance out the 2 positive charges from the magnesium +2 ion. Okay, so we can just crisscross those, and when we crisscross them, the number associated with the charge becomes the subscript. Okay, I'm going to do 2 examples for you. The first 2, sodium and chlorine, and then magnesium and iodine. Okay, so I'm going to come over here to my whiteboard. Okay, it might help if you guys write them out on paper. Okay, so my first one, so this is A. In A, sodium and chlorine are combining, right? So they've got to get close to each other. When they get close to each other, chlorine is going to steal an electron, okay? And that ends up causing, okay, sorry, let me get rid of that. Okay, let's see if I can delete it. Nope. Okay, I'm really scared. What if I hit delete here? Delete object. Okay. Why did it come back, people? Why did it come back? Okay, delete. Okay, so I've got sodium and chlorine. They're coming close together. Okay, and chlorine steals an electron. When it steals an electron, that means that it has more electrons than it has protons, and that's going to make chlorine have a -1 charge. Okay, because sodium has lost an electron, it will have a +1 charge. Okay, so we've got a -1 charge on chlorine, a +1 charge on sodium. So then what's going to happen is, okay, those charges, okay, the number associated with the charge essentially swaps. Okay, so it's going to come down here and become the subscript on chlorine. Okay, and so we've got a 1 becoming the subscript for chlorine. So let's drag that over. Okay, and for sodium, okay, we're going the other way. Okay, we are taking the number associated with chlorine's charge, and it's going to be the subscript for sodium. Okay, so that's a -1. The number, okay, is a 1, so that becomes the subscript for sodium. Okay, so now when I'm looking at when sodium and chlorine combine, they're going to combine in a 1-to-1 ratio and become sodium chloride, NaCl. Okay, let's look at the second one. So this is B, magnesium and iodine. Magnesium forms a +2 ion. So I'm going to drag that +2 over to magnesium. And iodine forms a -1 ion. Okay, and remember, in order to find the ions, okay, what ions are formed, you're using the periodic table, and at the top of the periodic table, the charges are listed for you. Okay, then I do my crisscross method, crisscross. Okay, and I take the 2, and that 2 is going to be the subscript for iodine. So I bring my subscript over, okay, and it becomes associated with the iodine. And then I crisscross on the other side. I take my 1, -1 associated with the charge on iodine, and the subscript of 1 goes with the magnesium. Okay, so I have a magnesium +2 ion combining with an iodine -1 ion. Well, in order to balance the positive and negative charges, I have to have 2 iodine atoms combining with 1 magnesium atom in order to make a neutral ionic compound. Okay, so when you go to then fill out the your answers here, okay, I'm plugging in those answers, Na1, Cl1. I've got to make them subscripts. In order to make them subscripts, I'm going to go up to the top. I highlight the number, go up to the top, hit Format Text. Okay, so Format Text, go down to Subscript, and then it'll make it lower. Okay, it'll make it a subscript text instead of, hey, a regular size text. Okay, so I did that with the other one as well. Okay, so again, you go to Format Text and then go down to Subscript. Okay, so that's how you create, and you just highlight the numbers that you actually want to make subscripts. Okay, and then I'll go back. Magnesium iodine, right? That was my second one here, magnesium iodine. So it was a 1-to-2 ratio. Okay, so I write in my magnesium and my iodine, okay, with their ratios, a 1-to-2 ratio. I make the 1 a subscript, and I make the 2 a subscript. And that's my chemical formula, magnesium 1, iodine 2. All right, ladies and gentlemen. Hey, I hope that helps you complete this part of the assignment. After this, you guys are going to work on slides 12, 13, 14, 15, okay, until you get to the very last slide. Okay, on the very last slide, there are a couple quick questions for you to answer. Hey, in order to answer these, you're going to drag the correct answer to fill in the blank. Okay, so we've got these down here at the bottom. Hey, you're going to pick them up and drag them to where they belong. Okay, so for instance, hey, an atom that gains 1 or more electrons it'll have a negative charge. So I dragged negative up here. Hey, an atom that loses 1 or more electrons will have a positive charge, right? So I would grab, hey, this box and drag it up. Okay, and you'll do that with the rest of the terms down here at the bottom until you have all your blanks filled in. All right, ladies and gentlemen, that's the sort of quick tutorial on how to complete the ionic compound puzzle activity. I hope that helps. Let me know if you have any questions.